Okay, hi everyone. Today we're going to do Cambridge IGCSE Additional Mathematics 0606 February March 2025 series, paper 2, variant 2. Okay, so the intended audience for this video is actually for the May-June 2025 for a last minute revision. So I'm not going to go through each step detailed one by one. So I'm going to assume that you guys already have a basic knowledge of all the knowledge. I'm just going to go through very briefly so that you consolidate all your knowledge to try and get you ready for the exam. Okay, so we're going to do paper 2 today. I did not read the marking beforehand, so maybe I can try to explain the thought process behind every question. Like, that's the first time I'm seeing it also. Okay, so let's get into it. Okay, question 1, there is a circular measure question. So there is a center O with radius 5. So let me just try and label the radius is 5. Radius is 5. Okay, and then A and B, they lies on the circle. So A lies on the circle, AB is a tangent. So once it says a tangent, so we know that this is a perpendicular line already. And OB has a length of 13. So this one is radius only. So OB is the whole line, it's a 13 cm. Okay, so that's all the information that we have. Let's try and do question A, which is find the angle AOB. So we want to find this one. Okay, I think mostly we can do with trigonometry here. We have the adjacent side. Okay, we have the adjacent side. We also have the hypotenuse. So with that one adjacent and hypotenuse, that we can use the cosine. Okay, cosine of AOB. So let me write here, cosine of AOB will be 5 over 13. So AOB, you can just press your calculator and remember to change it to radian mode. So press, and you should be able to get 1.176 radian, or to 3 significant figure is 1.18 radian. Okay, and find the perimeter of the shaded region. Okay, perimeter, maybe we can label the 5 cm back, and then also I can label the angle here, that's 1.18 radian. Okay, we need to find the arc length, and then also the side AB and this extended length of B lah. Right, so this length we kind of know already because this is 5 cm, so obviously this one will be 8. AB is quite easy to find also because it's a right angle triangle. We can use the Pythagoras theorem. So AB, you can just use the Pythagoras of 13 squared minus 5 squared. So there'll be 12, right? So this is 12 cm. Okay, the only thing left is the arc. Okay, the arc. With the formula, I mean, if you don't remember the formula, you can refer to the formula sheet. But r theta, and theta must be in radian. R will be 5 cm radian. Theta will be 1.18, and the answer will be 5.9. Okay, so the perimeter total, you have 12 adding 5.9 adding with 8, so 25.9 cm. Okay, that will be the final answer. Find the area of the shaded region. Okay, so now probably what we'll do is to do find the entire triangle first. Okay, minus off the sector area. So the whole triangle, that should not be hard to do because we know the height and we know the width also. So half of 5 times 12 minus off this sector area, that will be half r squared, r will be 5 in this case, and theta 1.18. And right, so let me try and type this into my calculator. I got 15.25 cm squared, right? So there's a final answer. Okay, find the x coordinates of the stationary point on the curve. This curve basically. So it's a cubic polynomial, and it presents itself as a product. So either you can expand it out or you can use the product rule. In this case, I'm going to choose to use the product rule because it's easier for me. So this coefficient here is a constant coefficient. I'm just going to leave it out there. And first, okay, maybe I will leave the first term, so 3 minus 2x, and differentiate the second term. So I bring 1 down by the power, and inside the derivative is 1, so I don't need to care about that. Then I'm going to add, okay, I leave the second term and differentiate the first term. So the first term differentiated will be just left with negative 2. Right, so I can simplify the half and this one cancels. So okay, so this is the dy dx in terms of x still, and they want the stationary point. So at the stationary point, recall that the dy dx will be 0. Okay, so what we can do is we equate this function to 0. Now what a lot of people will tend to do here, the mistake they will tend to do, oh, I think I did a mistake. So before this, this negative 2 I cancel out, but there should be still the negative here, right? So negative here also will be a negative. Okay. Okay. As I was saying, the mistake a lot of people will tend to make is they will, a common error right here. They will tend to move this to the other side, and then they will cancel off this square and this square, and what they will end up is with like this, and you end up with only one answer of x. Okay, x equals to some number, which is I mean, you're missing out on one answer here. So try and do it this way. Okay, this is not a correct, I mean, you're not getting the full answer. What you should do instead is you treat this as a whole like factor. We can factor out x plus 2, right? So I can take out the x plus 2 is good because it's a common term. So what I will get is x plus 2 minus 3 minus 2x, like that. So I will have two different answers for x now, because I mean, two products multiplied with each other equals to 0. Either this will be equals to 0 or this will be equals to 0. Right, so either x will be equals to negative 2 or this expression will be equals to 0 and x will be instead 1 over 3. Right, so you should have two answers here, and right, that's it. They did not ask to find the y coordinate, they only wanted the x coordinate. So this should be your final answer. Right? So, okay. Now part B, we want to use the result from part A to sketch this graph, stating the intercepts with the coordinate axis. So, with your knowledge of the polynomials, you know that basically the x-intercepts, it will be 3 over 2 and negative 2. You know this also. And you know that there will be turning points at negative 2 and 1 over 3. So let's keep that in mind first. But for now, this is the important thing. And you know, okay, so since the coefficient of the x's, they multiply to become negative, right? So the coefficient here is negative and the coefficient here is positive. So there will be it will be a graph that is going downwards. Okay, going downwards. So let's first sketch out the graph. Okay, maybe also I can find the y-intercept. So y-intercept, I can just multiply the constant. So it will be 3. Okay, the y-intercept will be 3. There's only two roots, right? So I need to keep that in mind also. So there will be one root where it's exactly at the turning point. So I'm going to draw like that, and then coming back down here. Okay, so first I'm going to label here is negative 2. Okay, only two roots, and here the root will be 3 over 2. Right, and then the intercept, that will be 3. Okay, and then of course the turning point here, this one actually, the turning point, you do not need to label it. You just need to label this one, the intercepts with the axis. So 3, negative 2, and 3 over 2. And we can label the graph y 3, negative 2x. Right. Okay, find the values of k for which this equation has 3 real and distinct roots. Okay, so from this graph, we need to find for which value of k they will intersect the graph 3 times. 1, 2, 3. So we can obviously see the extreme, the limits here will be from here. It has to be in between this point and also, also the x-axis lah, right? So k must be in between these two values. Yeah. So, alright, let's try and find this point. This point, we already know about the x coordinate of the stationary points, right? So from these two value, only this one will work, the 1 over 3, because here is positive. So this is 1 over 3, and all we need to do is actually sub it into the y, the equation of the line, so that we can get the value of y, which will be this point. So that will be your k value, right? So at x equals to 1 over 3, 1 over 3. Okay, so paper 2, you're allowed to use calculator, so I think better still if you just use the calculator to type this in. Okay, so the y value here will be 343 over 54. So, okay, that's your level here, 343 over 54. So what we want to do is to contain the k value between this point and the 0. So k will lie in between, not inclusive of, right? Because we want 3. Not, at this point there will be 2. If we include that point, there will only be two distinct roots, but we want all the 3 roots. So we do not include the point. So k will be in between this point and 0. Okay, and that will be the final answer. Okay, solve this equation giving your answers to 2 decimal places. This is a quadratic equation in disguise. So if you can immediately spot that there is one of this thing on the denominator, so I'm going to multiply the entire equation by that. And instead of adding the powers together, I'm just going to write it as x3 over 5 squared, so that it's easier to see that it's a quadratic in terms of x power 3 over 5. And I'm going to also directly move the 12 to the other side, so that, yeah, it's the quadratic. Now, I don't think this will be factorable. Oh, it is, okay. So, x will be 4 over 3, or x will be negative 3 over 2. Sorry, not x. Okay, so the careless there, also a common mistakes that people will do, just ignore the power. Okay, so do not ignore the power. We rewrite the power back there, then now we have to inverse the power or take the reciprocal of the power, so that 5 over 3 and 5 over 3. Okay, this one actually you can just type in your calculator. You don't need to give it in we need to give it in 2 decimal places, so just type it into the calculator. Sorry, 2 decimal place, not 2 significant figures. Sorry, got that mixed up. So 2 decimal place, 1.97, and for 1.6 there will be 1.62. Okay, so 2 answers, 2 decimal places. Okay, a team of 10 players can be chosen from 15 players. Find the number of different teams that can be chosen if there are no restrictions. So, for a team of players, we do not consider the order to be important, so we're using combinations. So 15, C, 10. So this one also you can type into your calculator, 3003. The 15 players include 3 sisters who must not be separated. Find the number of teams that can be chosen. Right, so we can separate it into 2 cases where the 3 sisters are playing, or the 3 sisters are not playing. right? And then we add these two cases together. So if the three sisters are playing, you will have them. I mean, you must have three on the field already. So your limit is you still have seven left, right? And how many else you can choose from? It will be 12. If without the three sisters playing, you have 12 people to choose from, and you still have 10 slots on the field. So that will be the two cases, and you can type this into your calculator also. So we get 858 different ways. Okay, part B. Now it's a 6-digit number from these few digits and cannot start with 0, and all 6 digits must be different. How many 6 digits can be formed if it's even? Okay, so I mean a number, definitely the order will matter, so we're going to use permutations here. Okay, we need to separate the cases where 0 is behind or when 0 is not behind. Right, so these are the two cases that we need to consider. So if 0 is not behind, this will be simple. It will be just 9p5 at the front here. So these all are free for all. Okay, and number will still be even because behind is still 0. But if 0 is not at the end, it could only be these four numbers at the last digit. So for the number to be even. And the front here cannot be 0. So once there is a number of these four that's being chosen as the last digit, the first digit will also be even more restricted, so it will be 8p1 here only. And once the two digits are chosen here, what's left will be just 8 more left, and these 8 are free for all. So here will be 4p1, 8p4, 8p1. Okay, so the first case, there will be 9p5, and we are adding together with 8p1, 8p4, 4p1. Right, so that will be 15120, and this one will be 53,760. So if add together the total comes out to be 68,880. Right. Okay, question 5 looks like a linear law question. When e power of y is plotted against x squared, a straight line graph with gradient -3 is obtained. So, okay, this time they are giving you the gradient straight away, so we can just write that down. M is -3. And our function in this case is e power y -3 x squared plus c, where c is the y-intercept. So the line passes through this point, so we can use this information to find our y-intercept. So remember, this is already our big y. This is a big x and big y, which is e power y and x squared, right? So we don't need to transform them into the variables again. Just use the values. So our y-intercept will be 18.75. Maybe you can use this to find y in terms of x. So that's the objective of the question. If you leave it like this, you are still gonna lose out some marks. So to find y in terms of x, we take the natural log, right? So this will be your final answer. Now, part B is more towards on the domain. Find the value of x for which y exists. So we need to know, first of all, what is the appropriate domain for a natural log curve. So if you can recall, natural log, it look like this. For the x values, it will never, or is asymptotic at 0. And when you try and type ln0 into your calculator, it will be a math error because it does not exist. Right, so whatever's inside the log function, it has to be greater than 0, right? Non-inclusive of 0. So we can just take the argument of the logarithm function and equate it, or put it into an inequality and try and solve for this. Okay, so the inequality, you can rearrange it so that we have x squared smaller than 6.25. Okay, so at this point, many students will be tempted to just do this and then call it a day. But if you can recall, for quadratic inequality, this is wrong, because what does a quadratic inequality mean graphically? It means like this. We have a quadratic graph, and we want to find where this graph value is less than this value. So if we try to rearrange it to its standard form, we need to find the roots, and since this is less than 0, the condition, we need to find where it's below the x-axis. So the x value will lie in between these two roots, these two values of the roots. So we need to try and do that. So 6.25, we can rewrite it actually as 2.5 squared, and with the identity of the quadratic expansions, so we know that this is true. And our critical values, okay, our critical values are x is plus minus 2.5. So obviously here is negative 2.5, here is 2.5. So our x lies between negative 2.5 and 2.5. So this will be our final answer. Right? So this will be the value of x for which y exists, or rather the domain of the graph. Okay, it's given y is this function, and we want to find the derivative. So okay, it's a quotient, or it's a function divided by another function. So we have to use the quotient rule, or you can, if you prefer to do the product rule by rewriting it as a negative exponent, that's fine also. But I will just do the quotient rules because it's easier for me. So first we bring up the bottom function, and we take the derivative of the top function. So ln, that's 1 over the inside function multiplied by the derivative of the inside function. Okay. Then we subtract the derivative of the bottom function. There will just be 1, so I'm not going to write it. And we leave the top function as it is. And everything divided by the bottom function squared. So this will be the dy dx of the function. So we can just leave it like this. We do not need to simplify it any further. Okay, given that x increases from 2 to 2 plus h, where h is small, find the approximate change in y. So we know that the change in x will be h. Okay, so we want to find the corresponding change in y, and we know that since the change is small, we can approximate it to the derivative at evaluated at that point. So we also know that the corresponding change in y will be the derivative multiplied by the corresponding change in x. So all we need to do is find or evaluate the derivative at x equals to 2. Okay, so can directly sub it in, or if you know how to use your calculator to type it, that's even better also. Right, so the gradient or the derivative evaluated at x equals to 2 results with this value, and so the corresponding change in y will be 0.0849 h. Okay, part C. Given that y is decreasing by 0.4 units per second, find the corresponding rate of change in x when x equals to 2. So we know that dy dt, alright, so y is decreasing by 0.4 units per second. So if we have units per second, this is time. So that's a time derivative, and it's decreasing. So it's a negative 0.4. So what we want to know is the corresponding rate of change in x. So this is also the time derivative of x. when x equals to 2. Right, so we want to know dx dt. So to do this, we would use the chain rule. So we have we have dy dx that we know, and it's also evaluated at 2 already, so that's convenient for us. So to convert dx dt to from dy dt, we can do this dx dy and dy dt. So what it looks like is dy dy cancel, right? So we can do that, and dx dy is that's the reciprocal of the dy dx, right? So what we need to do here is 1 over the dy dx evaluated at x equals to 2 and multiplied by the dy dt, which is negative 0.4. So negative 0.4 divided by 0.0849, you can type into your calculator, you should get negative 4.71. And the units not so important in mathematics, mathematics module, but the units will be units per second as corresponding to the time derivative of y. Right. Right, so for question 7, we are given two functions and we want to find the value of a such that this function composite gf exists for all x greater than 0. So maybe it's convenient if I just write out what is the composite function first. So we're given that the composite function is a square root, and we know that for a square root to exist, the inside of the argument has to be greater than 0. So we can just write it out first. Greater or equal to 0. Okay, so when we evaluate this function at x equals 0, because we know that this one will strictly increase, so we don't really care about that. So we just want for the case where x equals to 0. So this term will become 1, so I'm just not going to write that. And a, we can see that it has to be greater or equal to negative 1. Right, so this will be the greatest value of a such that this function exists. Right, in the case where a equals to 5, solve the equation gf equals to 3. Give your answer to 3 decimal places. So we can just write we can write the composite back here. And I'm just going to directly replace a as 5. So this is the function. And we know that it's the value is 3 at this point. So we can solve it quite easily, just doing a few algebra steps. So the answer wants to be given in 3 decimal places, so we can use the calculator here. So 0.916. Right. Show that this expression can be written as a sine cube. Right, so first of all, I think I can notice that the bottom can be written as secant square already. So the bottom is secant square, right? Based on the three Pythagorean identities. So you can refer to the formula sheet at the beginning of the paper. Right, this one, the second one, a1 plus tangent square, is equivalent to secant square. Right, and then I think tangent square, I'll rewrite it as sine squared cosine squared. Right, so this entire left hand side, I can transform it to sine theta, sine squared, tan squared. Alright, so at this point, I can combine the numerators here, and secant squared, I can actually rewrite it as the third letter is c, so 1 over cosine squared. Right, so sine squared or sine cube theta cosine squared theta 1 over cosine squared theta. So these two cancel out, and what I'm left with is just sine cube theta. So that is now the equivalent of sine cube. And hence we want to solve this equation within this interval of x. Right, so given that we've already proven this result, so we can just use it, and the only thing we need to change is that the theta, we can replace it with 3x. Sine cube of 3x will be equal to 1 over 8 for this value of x. So actually our argument in the trig function is 3x, so I'm just going to change the range or here. So it will be 540, 540. And right, so now we have to get rid of the cube, and it's half, right? So now sine, for this equation, sine is positive value. So the solution exists in quadrant 1 and 2 only. Right, so now we can find the basic angle. Right, if you want to practice without your calculator, you can draw the triangle out with sides 2, 1, 0, 3, right? So this will be 60, 30. And for half, for sine, hey, draw it wrong. This should be 2, and this should be square. Sorry. This should be square root 3 and 1. Right, so for sine, we look at the opposite and the hypotenuse. So the opposite and of the 30 will be 1, and the hypotenuse will be 2. So our basic angle basically will be 30. And we want to see all the solutions within these two, or this range of angles between the first and second quadrant. So we will have 3x, actually quite a lot of solutions. So 30 and 30. So first we're just gonna go clockwise for the positive angles. So 30, 150. Then we can even go one more round for 390 and 410. Right, I believe if we go one more round, that will be over already. Yeah, sorry, this is 510, not 410. Right, so now we can try and consider going the other way, which is negative angle. So when we even when we go to clockwise direction, we still need to consider that the quadrants do not change. It does not mean that when we spin this way, quadrant 1 is here now. So that's one of the common mistakes that students usually make. Right, so, and also remember that the angle when we spin this way, the angle we take is with reference from still this axis. So when we spin here to this angle, the angle will be, instead it will be negative 210 degrees. Right, and then the subsequent one will be negative 330. And so can we go one more round? No, we cannot. So the next one will be out of the range already. So this is all the solutions that we will have lah. Okay, so when we divide everything by 3, right, so we will have 6 solutions here basically. Right. Okay, question 9 is a kinematics question. So we are given that the displacement from O is given by this function. Right, so for part A, we want to find the value of t for which p is instantaneously at rest. So at rest means that the velocity is 0. So to find the velocity, the function of velocity, we have to take the time derivative of the displacement. And in this case, the derivative of this Ln graph will be 1 over the inside function, and then multiplied by the derivative of the inside function, and negative 5t will just be 5. So this will be the simplified version. And at rest, we just need to equate this to 0. Right, so this will be the time where p is instantaneously at rest. Right, so for next question, find the distance p travels between 0 and 2. Right, so now we need to be slightly more careful because we want to find the distance that it travels. So we know that t comes to rest at 0.5 seconds or half a second. And there, I mean, from this equation, we know that there is no other values of time where it changes direction. So we need to be careful of this. And probably you can sketch the graph out. It will probably look like something like this. Again, it's just a sketch. So vt, right? So at the first moments, it will be traveling backwards or in the opposite direction, and then after a while it will be traveling in another direction. So that's why we need to consider or evaluate the distance from 0 to half and only from half to 2. Right, so the area underneath the curve, we must make sure that we take the positive value so that we do not get the wrong result. So what our distance, it will be actually the modulus of s evaluated at half minus s evaluated at 0, adding together with s evaluated at 2 minus s evaluated at half. So we can try and evaluate this. S evaluated at half, going to get right. So this will be the substituted values. So you can type this into your calculator. So the final answer should be 3.88 meters. Oh, sorry, positive 3.88 meters. Right, find the expression of acceleration of p in terms of t. So we know, recall that from displacement, we differentiate to get velocity, and we differentiate again to get acceleration. To go backwards is just integration, right? So we already have the expression for, I mean, the velocity here. So we just have to take this derivative again. So I'm going to copy down. And with this, we can take the derivative. And yep, that should be it. And now we want to find the acceleration when t is 4.5. So you can just substitute the values in. The unit will be meters per second squared. Right. Right, so now we come to question 10, which is binomial expansion. Right, so this multiplication of a binomial expression is written in descending powers of x. And the first three terms are this, where a, b, and c are positive integers. So we want to find the values of a, b, and c. Right, so this is a 10-mark question, and it will be quite long. So obviously, for binomial series, we're gonna write down the formula first. So the general formula of a binomial series be Right, so this will be the general formula for a binomial series, where this NR is the combination. Okay, so we can slowly expand this. Alright, so the all we need actually is term up to x squared here. So the rest, or the lower powers of x, we don't really need to consider here. Alright, and then for the next series, right? So that's that's all the terms that we need to expand, right? So we want to consider only the top three powers of x. So x power 4, x power 3, and x power 2. So for x power 4, we can try and look at which one multiplies together to become x power 4. So only ax and 1 multiplies together, right? So for the coefficients of this, what we can do is we can just equate a power 4, we can equate that to 81. So we can get it, you can get the numerical value of a to be 3. Right, for the next one, for the coefficient of x cubed, we can look at, right, x power 4, we can multiply that with 3b over x to get x cubed. And also we can get this one, multiply with 1. So what we have will be 3b a power 4 minus 8a cubed equals to 999. So with this substitution, I believe you should be able to get b will be 5. You can just use your calculator to type this out. Right, so a equals to 3, b equals to 5 so far. Next will be the x squared coefficient. So for x squared, we have slightly more. This one multiplied with 1, x cubed multiplied with this, x power 4 multiplied with this. Right, so that equals to c. Right, so you can just type your calculator, you should be able to get c. C will be 3051. And so there will be, it's a lot of work, but the working does not look quite long. So you just need to be able to make sure that you multiply and collect the correct terms and use the formula correctly. Right, so that will be question 10. Okay, last question, question 11. Solve a trigonometric equation for a given range of y, where y is in radians. So first thing I'm going to do is switch my calculator into radian mode. And cotangent, the third letter is t, so it will be 1 over tangent. Y plus 1.5 is 3. Alright, so maybe I was also going to change this range so that it's easier for me. Right, so I know that my basic angle lies between these two values. And no tangent, 1.5 is 3. So as before, tangent is positive, so it exists in first and third quadrant. And we can, sorry, this is 1 over 3, right? So we can type your calculator for the basic angle and you should be able to get 0.322 radian, of course. And right, so now we need to figure out what is the range of, figure out what is the other values of possible answer for this y plus 1.5. So yeah, we know it exists in the first and third quadrant, so that's what we were going to focus on. So it's 0.322 and 0.322 here. Right, so probably first we're gonna add pi, right? Because this is 0 pi, then or 2 pi, right? Then also we're gonna have 0.322 adding with 2 pi. So I think I'm going to stop there for now because I believe that is gonna be almost 7 already. Okay, so let's see what the value is. So maybe I can take it one more time. So 0.322 adding with 3 pi. Yeah, that would definitely be outside the range already. So I'm just going to stop here at 6.61 as my final value. So remember to subtract the 1.5. So 2.96 here and 5.5. Sorry, 5.11 here. Right, and of course these are in radian. So radian. Not 2.96, 1.96. Sorry, 1.96. Right, so this will be the last question. And yeah, all the best for your exams.